Hey everyone! Today we're diving into something really cool. It's a brand new tool that's basically a detective for artificial intelligence, and its job is to figure out exactly how AI teams get things done.
And that's really the big question, isn't it? When a whole team of AI succeeds, or maybe even fails, it's almost impossible to figure out who the star players were, and, who was just dead weight. Well, until now. So, before we can really appreciate our detective, we have to understand the crime scene. And in the world of AI teamwork, that scene is often a total mystery, what we call a black box. We might not always notice them, but AI teams are already making huge decisions all around us. I'm talking about coordinating fleets of self-driving cars, managing our power grids, and running automated factories. These are seriously complex jobs that demand real, collaborative smarts. Okay, so here's the problem. We see the final result, right? The cars avoid a crash, the factory hits its target, but we have practically zero insight into the how. How did they decide to do that? Which AI made the key move? When things go wrong, not knowing is more than just confusing, it can be downright dangerous. So to crack open that black box, researchers have built a new framework, and they've given it an awesome name. MACIE. Seriously, just think of it as a specialized investigator, a detective for AI teams. MACIE. It stands for Multi-Agent Causal Intelligence Explainer. But what it really does, its entire method, is built around asking, what if? It doesn't just look at what happened. No, it runs all these simulations to figure out what would have happened if just one AI had done something different.
So how does this AI detective actually pull it off? To really get it, we need to take a peek inside its toolkit. And it's all designed to answer three very specific, very important questions.
First up, attribution. Who actually gets the credit or the blame for how things turned out? Second, emergence. Was this real teamwork? Did the team achieve something that was way bigger than the sum of its parts? And finally, actionability. How do you take all these complicated findings and turn them into something a human can actually look at and understand?
The secret sauce here is something called interventional counterfactuals. I know, it's a mouthful, but the idea is actually pretty simple. Imagine a coach trying to figure out who their most valuable player is. They could replay the game over and over, but each time they sub out one player for a totally average random player. By seeing how much the team's score drops, they can figure out exactly what each star player was bringing to the table. That's what MACIE does.
And honestly, this causal approach is a massive leap forward. See, older methods, tools like Lime and Shap, they're mostly correlational. They can tell you an agent's move is associated with a good outcome, but they can't tell you if it caused it. MACIE is different. By running those what-if scenarios, it pins down direct cause and effect, which is absolutely critical when you're trying to untangle that complex dance between a bunch of different AIs. Okay, enough with the theory, let's get to the good stuff. Let's open up the case files and see this detective in action, solving some real mysteries from the world of AI.
So, first case up, we've got a team of 3 AIs trying to navigate a space together. Now, MACIE's analysis came back with something, well, kind of weird. Take a look at these scores. Agent 1 is at -6.6. Agent 2 is worse at -9.4. And Agent 3 is all the way down at -10.5. Just looking at this, you'd think every single one of them was a total failure, right?
But here's the twist. This is where the detective work pays off. Despite those terrible-looking individual scores, MACIE calculated a synergy index of 0.461. What that means is that through teamwork, by working together and avoiding collisions, the team performed a whopping 46% better than you'd expect. That's true emergent intelligence. They were so much better together than they ever could have been apart. All right, case file number 2, a classic predator-prey game. And wow, the results here are like night and day. MACIE found that Agent 2 is actually helping the team, with a positive score of over 3. But look at Agent 1. Its contribution was a disaster, a -8. This agent wasn't just slacking off. MACIE's analysis showed it was actively sabotaging the mission. So get this. This is the absolute killer insight. When MACIE ran that what-if scenario, it found something incredible. When they replaced the supposedly smart Agent 1 with a totally random, clueless agent, the team's performance didn't just get a little better, it actually improved. Its strategy was so bad it was literally worse than doing nothing at all. This is the kind of mind-blowing detail that was just impossible to see before. So you can see just how powerful this kind of detective work is. And it's not just about giving AIs a report card. This is all about building a future where we can actually trust the AI systems we rely on. So why does all this matter so much? Well, for developers, it means they can debug these complex AI teams with pinpoint accuracy. For the rest of us, it means real accountability. We can finally get clear, transparent explanations for why an AI system did what it did. That makes things safer because we can find hidden flaws, and ultimately, it lets humans and AIs work together in a much, much better way.
Which brings us right back to that first question. If a team of self-driving cars causes a crash, who's responsible? For years, the answer has basically been a shrug. But with a detective like MACIE on the case, we're stepping into a completely new era. An era where we don't just see what AI teams do, but we can finally understand why. And that changes everything.